Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 86. Maximum number of robots within budget. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. So, also, I hope you enjoyed the intro. I'm in Antalya, in Turkey. Yeah. That's pretty much it. I just hope you enjoy. Anyway, today's poem is the maximum number of robots, and this one's a little bit tricky. I actually ate a lot of wrong answers. The first and took a long time. I think the first one was. I actually solved this in about 5 minutes. If I had read this correctly, maybe. The idea here is that well, the first mistake I made was that I missed the consecutive part. So I was actually solving another version. For up solving, see if you can solve it without the consecutive version. But the way that I did it now with consecutive will require something called the mono queue. And I actually have a long video about it, so definitely check that out. But that's it. I have a long video on it, check it out. But that said, I did make a mistake in today's implementation, so what are you gonna do, right? But you can find it here under Larry's Explains on my channel. So if you're here, then just click on the Larry, and then there's where's it? Oh, Larry Explains here, and then there's a mono queues part 1, part 2. So definitely check that out. But the idea here is that we use a mono queue to keep a sort of a max over sliding window. So that's basically the idea we have here, and I'll go over the mistakes that I made in a little bit. But that's basically the idea, and once you have that idea, then that's pretty much it, right? So the idea is that because you have to get consecutive, it's a subarray situation. And for a subarray situation, we basically have a right sliding window and a left sliding window, and then we slide to the right. See if it go over the budget. If it's over the budget, then we slide to the left to make it smaller to keep things cheaper under the budget, and keep on going, and then keep on going to the right as we can until we can't anymore, and then go left. That's basically the idea, really. And it's a sliding window thing, which is something that is a stable in both Leetcode and probably a lot of interviews now. So definitely, get familiar with the concept. But here, the mono queue is a fancy term, but it's just an invariant situation. Definitely check out the video to kind of go over how you build from mono queues. That said, I did make mistakes, and let's go over it real quick with the sliding window. And this is just sliding windows, really. Basically, I moved to right, and then when I moved to the right, there's a current sum. I added to the running cost of the thing that we just slide. We add 1, and then here we have a mono. This is the max queue, and yeah, and basically, the way that I ask myself how to write this is that, okay, if this number that is incoming, if that is the new max, what cannot be max anymore, right? Well, what cannot be max is all the previous numbers that are smaller than it. So then that's why I have this pop here, and then I append this max to the right. And because we already eliminate all the numbers that are smaller than it, so the max will be the first element. And that's basically the idea. And then we calculate the cost. This is, of course, in the problem statement. And then while cost is greater than budget, I subtracted from the given a sliding window, if the left side, I don't know if I mirrored, but my left side, if that is making the cost too much, then we subtract it, right? That will always give us a smaller cost because of how the formula works, and so then we're able to do it. So then here, again, if the number that we pop off is the max, we pop the max from the max queue, and then we increment by 1 on the left, and then we go on. Yeah, that's pretty much it. And then otherwise, if it's counting to 0, we break, because that means that we don't have, left is equal to right, and we also don't have any elements. Otherwise, this would fail. And actually, that's what happened to me. I actually did not. I just didn't, because very often in these things there are ways to kind of the invariants don't change, and then you don't have to take care of it. explicitly, but in this case you do, because in this case the cost should be 0, but this freaks out because there's no max, right? That's basically the idea. And I actually, so that was one error, one wrong answer. The second wrong answer was that I actually had this here, so then it was decrementing before, so it was decrementing from the same left multiple times. So a lot of silly mistakes, but overall the idea is right, and that's pretty much it. And then after this loop ends, or if it's equal to 0 because there's no elements, then we know that the cost is less than budget or equal to. So then we could do a max on the count, and that's pretty much it. What's the complexity here, right? Well, this is everything. Take a look at every operation. Every operation is going to be O of 1, and because there's an O of n loop, this is going to be O of n. So linear time and linear space. The only thing that may be a little bit tricky looking is this, and this while loop inside the for loop, and also this while loop inside also the for loop. The thing is that each element can only be pushed once and popped once, right? So in that sense, this for each element, if you look at it for each element in the input, they're only going to this is going to only happen once, and this is going to only happen once. Well, it could also be popped here, but you get my point. The point is that each element can only pop once and push once, so that means that amortized, it is going to be linear time, linear space, and that's pretty much it. That's all I have for this one. Yep, this should see the entire thing. Let me know what you think. Stay good, stay healthy. Oh, wait, you can watch me solve a live in contest now, keeping in mind that I solved the wrong problem in the beginning. So you can either kind of see if that makes sense and educate yourself, or just skip through it if you like. I don't know. Anyway, that is what I have for now, and you can watch me solve it live during the VC now. Why I'm such an idiot. It's okay. Luckily, this is VC, right? Not a real one. But that's pretty sad, actually. Okay, maximum number of robots within budget. You have n robots, you have 0 index integer arrays, charge times, running times, both of length n. What does that mean? Okay, so n is just the length of these things. I robot cost to charge and cost to run. You also give me a budget. What is n? Okay, n is big enough that it is not like some brute force DP thing, but it's not like a naive one. Total cost of running k chosen robots. Go to max of them plus k times sum of the running costs. Okay, so return the maximum number of consecutive robots you can run such that the total cost. Okay, I feel like this is some sort of sorting algorithm. Budget is pretty big, but that's fine if it's sorting. If we sort, what do we want to sort by? Well, one of them is going to be prefix sum on the running count. Is it? We want to, so okay. So let's say we want one robot. What would be that robot, right? So maybe we can figure out how to sort by that. Is there an exchange argument? So let's say we want one robot, right? What's the cheapest for one robot? Well, one robot is going to be max charging time plus plus, so if we add one more, then the cost of it is going to be, what's the delta of it, right? Well, the delta is just the existing running costs plus the new running cost times k. So it's k minus 1, and then is there some way of doing a repeated sorting thing? It doesn't seem like we care about, actually that's not true. I guess charge time could be pretty big, but charge time, it's only 10 to the 5th, so can we abuse that? Okay, I see. Can we do binary search on the charge time? Because for a given charge time, we can sort everything, right? So that means that we can do a heap thing on the running costs and then just sort by charging time. Is that true? I don't know if that's quite the way to do it. But let's say we have max charging time. Okay. Let's say we have max charging time and then we greedily sort and then heap. Can I? Okay. So in that case, it will be binary search on charge time, which is 10 to the 5th, which is like less than 20. And then that we do a sort. Well, we do a thing and then a sort. Is that incremental? Or like, is it because you can imagine that as charge time gets bigger, does the running cost have to be bigger? I don't know. Okay. So I guess we can do some sort of charge time incremental thing. So basically we increase it by whatever. And then now we can do a heap to kick things out until it's cheap enough, right? Yeah, and then basically we keep a running heap of the running costs. We keep the min of that, and then as we increase charging time, we do stuff. Wow, are people done yet? Oh wow, a lot of people are done, and a lot of them don't have silly mistakes like I do. Okay, but I think that's right. Okay, so basically we want to sort by whatever. Right. So then we want to sort this by actually just this, right? I think this is good, maybe. Because basically I want the sorting time to be 1, 3, 3, 2, 3, 4, 4, 5, 6, 1. Okay. So then now what we do is what do we say? So what is the right or the good way to phrase it, right? I guess we could have done it another way, but that's fine. Okay. So that means that when we add it, let's see. Basically, the invariant, we keep going, right? So, okay. So, current cost is equal to 0 or something like that. And then for charge time, running costs, let's just say time and cost in items. What do we do? So, well, max time is equal to 0 for now, and then running total is equal to 0 as well. So here we set max time is equal to max time and max time, whatever. I guess we just set to time because it's incremental anyway. So then now the current cost is equal to max time plus running total, while current cost. Okay, so here we also want to let's say we have a heap, and then for that heap we add, do we want a min heap or the max heap? No, we want a max heap because we want to remove the most expensive stuff, right? And here we add max heap priest. Let me just rewrite it, max heap priest. So we want to add the cost, right, as a negative, and then the running total add costs. Okay, and then items maybe or count is equal to 0, and then we just count is increment by 1, right? So then the current cost is max time plus running total count times running total, right? Okay, and then we push this thing in the heap after we considered it. Okay. Also, we just have the best for most answer. Unless I missed something, is it consecutive? I heard. What does consecutive means? Like, is this a subarray thing? Hopefully, I didn't misread that, because consecutive just means really weird. When it is so not precise. Okay, okay. So then now, while current cost is greater than budget, then we do the C is equal to hip Q dot hip pop of H negative. So then now the running total, we minus this C count, we decrement by 1, and then now we have this thing. Okay, and then at the very end, the invariant is so best is equal to max of best and count, and then we just return count or best. Whoops. Hopefully this is, I think the idea is right. 3 and 0. Okay, let's give it a submit. Oh no, huh? I don't know if I expected this to write, but I was half expecting it. How are people doing? Okay. Okay, so I think this is 6, but it should be 4. Did I misunderstand the consecutive part? So we can choose any robots, right? And then the sum of the running costs. Okay. They don't explain what consecutive means, so I think they only explain. Okay, I think I misread this problem then. And also, that's really sad because the consecutive part is not really that emphasized. But okay, let's think about this again then. I misread this again. Okay. Yikes. I mean, this is just sliding windows then, right? Okay, fine. So for, let's say, oops, n is equal to length of charge times, and then for right in range of n, and then now we have to, this is actually much easier, to be honest, than the thing that I, or at least in terms of proving, current max is, we want a mono Q, right? Yeah. So we want a mono Q. I have to prove this every time, to be honest. I always forget how to do the mono Q. But for the max, and then the running cost is just total currents total, and then left is equal to 0 maybe. Current sum is equal to 0. And then here for right, let's say current sum, we added to the running costs, count increment by 1, as we say. And then now we have to get max is equal to Q of 0, I think, right? We have to do the max first. So then here, if this is the max, it's going to be the max going forward until this pops out. So while length of Q is greater than 0 and Q of -1 is less than less than what charge times of right, then q dot pop right, and then otherwise and max is equal to this, and then now yeah, so then now cost is equal to count times, what's it called, max plus count times current sum. What is this? Running cost of right, that's not even, I don't know what happened here. Okay, and then here we do while cost is greater than budget, we move left, so current sum, we actually, this is very similar to the stuff that we actually already have, to be honest. Left increment by 1, and then while length q is greater than 0, and q sub 0 is equal to charge times of left, then q dot pop left. Actually, this is just an if because we only remove 1, so don't remove more than 1, please. And then here, oops, after that we make sure here, and then we can do best is equal to max of best of count, same as before. I can't believe I can't believe I misread this as well. Well, I kind of was thinking about it, but I didn't know what they meant a little bit, and somehow it worked for test cases. So oh well. And I was a little bit sloppy on the thing. Why is the budget 0 or something? No. How can the oh well, if there's no items, does that work? Okay, fine. If count is equal to 0, we break, I guess. Okay, was that supposed to be 6? Doesn't even tell you the answer. Okay, fine. That one is on me though. Hopefully that's it. Oh no, did I misread this? I don't get how. Is this the same input that I failed the same one that I had before? Oh, because I had a thing, and then now because they didn't tell me the answer, I didn't check it. Oh man, wow. So the answer is 185. This is, I guess so. I mean, I believe them, but why am I doing 6? Print cost count. Did I not decrement? No, I did decrement. But I decrement. I think I have to do that. That's why. That was just sloppy because I added the if statement without really thinking about it. But yeah, I really needed the left before. So, yeah. That said, I wish they told me the answer, so then I would have debugged that as well. Hopefully now this is it. Come on, please. Okay, that was just a lot of silly mistakes. Maybe because I'm on my... Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm, this contest, and everything in between. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.